Okay, general calc type questions on this video. So increasing, decreasing, tangent line, sort of stuff like this, just sort of general calculus type stuff, sort of a vague topic, I guess. But let's look at an old AP question from last year, which I think is a pretty good example of things they can do on this year's exam given the sort of current format. So this one is number 6 from the 2019, so last year's AP exam. F, G, and H are twice differentiable functions. That is a very, very telling statement, but very, very succinct. So it tells you that they're differentiable, but differentiable also means that they're continuous. So that's going to kind of be a huge thing in this particular problem. Twice differentiable just means we're good for the first derivative, we're also good for the second derivative. Next, G of 2 and H of 2 are both 4. So F and G are graphs that intersect at 2, 4. And y equals 4 plus 2/3 times x minus 2 is tangent to both f and g, since that's a point they touch at x equals 2. I don't know why this equation isn't written in the standard point slope form with a 4 on the right side. It's kind of weird. It seems more normal. We've been writing it with a minus 4 on the left side. It doesn't matter. We're sort of okay here. So for part A, it just asks you to find h prime of 2. Not a lot of work to do with this question because they told you that y equals 4 plus 2/3 times x minus 2 is tangent to h at x equals 2. And the derivative gets you the slope of the tangent line. And the slope of the tangent line is just sitting right there for you to pluck out. So the answer to part A is just a nice, easy 2/3, and we can just pretty much move on to B. So not a lot of work to do. You just have to recognize that the slope of the tangent line is the derivative of the function at that point. So we can kind of go backwards. Instead of here's an equation, plug in a number to get the slope and plug it in here to write the line, they've already written the line for you, and you're going backwards to tell them what the slope is. Part B, a little more harder, a little bit more work to do, but it gives you this fourth function. We have f, g, and h, and now they're adding a to the mix. And a of x is 3x cubed times h of x. And they want you to find two things, a prime of x and then a prime of 2. So you can't really find a prime of 2 until you've found a prime of x, so let's knock that part out first. A prime of x is 3 comes down, that makes that 9x squared times h of x plus 3x cubed times h prime of x. We're pretty much just flying through our product rule where this is our u and this is our v. So that's our u prime, that's our v, plus that's our u, and that's our v prime. But we're pretty much done here. As far as finding a prime of x, now we just need to plug in 2, and whatever we wind up getting is the answer to this. So a prime of 2 should be 9 times 2 squared times h of 2 plus 3 times 2 cubed times h prime of 2. 9 is 9, 2 squared is 4, and h of 2, they told you at the top of this problem, is 4. So throw down a 4, plus 3 times 8. H prime of 2 is our answer from part A. So that's just a 2/3. Sort of works out nice. 4 times 4 is 16. 16 times 9 should get you 144. Plus 3 times 8 times 2/3. I would just cancel this 3 with this divided by 3 and just get an extra 16. So I wind up getting 160 for the second part of part B. A prime of 2 winds up being 160. 2 more pieces to this equation. It's kind of a long one, lots of words. There's a part C and a part D. Part C is fairly intricate with a lot of things sort of given out to you, and we'll sort of go through those steps, well, right now. So I just need to get this erased a little better, and we should be kind of okay to go. So part C asks you to find the limit as x goes to 2 of x squared minus 4 over 1 minus f of x cubed. And it wants you to find f of 2 it wants you to find, eventually it wants you to find f of 2 and f prime of 2. And it tells you that this function is named h of x. But they eventually tell you what this h of x function from the beginning of the problem is. H of x is x squared minus 4 over 1 minus f of x. But if you try to do the limit as x goes to 2 of the h of x function, you need to use L'Hopital's rule. And then ultimately it asks you to find f of 2 and f prime of 2. That's the kind of nuts and bolts from the big blurb they're giving you in part C. So, if we try to do the limit as x goes to 2 for this x squared minus 4 over 1 minus f of x cubed function, up top you're going to get 2 squared minus 4, which is 4 minus 4, which ultimately is 0, over, well, we don't know what f of x is, so you can plug in 2 if you want. But ultimately we can't cube it or do anything with that because we don't know what it is. So the key important takeaway from this question is you can do this limit with L'Hopital's rule. And L'Hopital's rule doesn't always work. L'Hopital's rule only works if the function was, if the limit was an indeterminate form to start. And so if the top is 0, this is kind of a dead giveaway that the bottom is also supposed to be 0. So what we can take away from this is 1 minus f of 2 cubed has to be 0. So we're good to go. You might be able to tell right away that f of 2 is 1 here, and they're fine with you doing no work. But if you need to do work, you can add this to both sides, take the cube root, doesn't matter. But you should be able to see pretty quickly that f of 2 is equal to 0. Or sorry, is equal to 1. 1 minus, if this was 1 cubed, you're going to get 0. So f of 2 has to be 1. So now that we know f of 2 is 1, we're pretty much just good to go. So let's officially use L'Hopital's rule. The derivative of x squared minus 4 is 2x. The derivative of 1 is nothing. Don't forget this negative. But this 3 is going to come down. Negative 3 times f of x squared back inside for f prime of x. So now we can just plug in 2, and we should be okay. So you get 2 times 2 over negative 3 times f of 2, which we just found 2 seconds ago, was equal to 1 times f prime of 2. Which is the other thing they asked you to find, which is what is f prime of 2. So ultimately, other key thing here is that these statements they told you at the beginning. The function being differentiable means it's also continuous. And if it's continuous, then when x gets really close to 2, the value should be 4, because this function was the h of x function. So we actually already know that the limit as x goes to 2 of h of x has to be 4 because we're continuous there. So you know what this limit is equal to. It's equal to 4. So 2 times 2 over negative 3 times f of 2 squared times f prime of 2 is 4. You just have to solve this little equation, and then you're basically just all done with this thing. So what you should wind up getting is 4 divided by negative 3 times 1 squared times f prime of 2 has to be 4. You can cross multiply and do a bunch of stuff here. I would just put a little 1 on the bottom of this 4. And since the top of both of these fractions are 4, that kind of means the bottoms both have to be 1. That way when we divide, we get the same answer. So I can conclude pretty quickly from this statement that the bottom of this weird little limit thing has to be 1. So that means negative 3 times 1 times f prime of 2 has to be 1. If you divide by negative 3 real fast, you should get that f prime of 2 is negative 1/3. So kind of an intricate, elaborate, weird way of getting you to do L'Hopital's rule on part C. Kind of tricky. But the key thing is differentiability implies continuity, so we should be sort of okay there. And then the last part of this weird little question gives you another function, k of x, and asks you some weird sort of stuff as well. So the big takeaway in this question, I guess, is going to be they're going to ask you if k is continuous at 2, and we need all this information they give us at the beginning, which is g of x is less than or equal to k of x, which is less than or equal to h of x. So they want to know if k is continuous at 2. So what we need, the definition of continuity, let's just go with k because that's the function they're asking you. You need k of 2 to be equal to the limit as x gets close to 2 for k of x for this thing to be continuous at 2. So I think we should be basically just good to go and kind of just go through this function and let's just do it. So g of 2 has to be less than or equal to k of 2, which has to be less than or equal to h of 2. And g of 2 and h of 2 are both 4. So that's a nice way, by the squeeze theorem, you kind of know that k of 2 has to be 4. So we've got a value. We just need to see if it's the same as the limit as x gets close to those things. So we've got this statement, and we can kind of use it here, and we can use it again with limits. That the limit when x gets close to 2 of g of x has to be less than or equal to the limit when x gets close to 2 of k of x, which has to be less than or equal to the limit when x gets close to 2 of h of x. And again, g and h are differentiable functions, which means they're also continuous functions. So there's some nice, easy, friendly, smooth, connected curve. So if the dots are at 2, 4, when x gets really close to 2, this guy has to be 4. And this guy has to be 4 as well. So we squeeze theorem a second time, this time with limits, and we get that the limit as x gets close to 2 of k of x is also 4. So as far as like a quick little thing, summarizer at the end, k is continuous. Don't forget to say this part. At x equals 2, because k of 2 equals the limit as x gets close to 2 of k of x. They both happen to be 4. Done. Kind of a long question, but sort of how I expect it to be formatted, or similar things where they don't actually tell you the function rules because this is going to be like an open note type thing. Anyway, that's the first thing for general calculus. Hopefully this video helps, and there's going to be some more. 3 more, I think.